Hello students, how are you all? I welcome you all to the class. Till date we have studied about motion in a plane and I have told you also about relative motion. In relative motion we have talked about the riverboat problem, the rainman problem, and we also discussed about graphical representation of certain variables like xt graph and vt graph, and then I showed some example how you can make other graphs using some given graph. And I know that you would have practiced problems and the understanding would be very simple in your mind, the concept would be very much clear with you all. Let's go today, let's not limit ourselves with only studying motion in a straight line. Today we'll start studying motion in a two-dimensional plane, that is in a two-dimensional space. That is, let us take an example. Suppose I have this chalk holder and if I throw it, it will come back. It was following a straight line path, it again came back along the same straight line path. So such is a motion in a straight line. Now suppose I throw the chalk making some angle with the horizontal, like say in this way. So this time it is not moving along the straight line, but there is some other kind of path, but certainly it's not a straight line path. So we can say this chalk holder moved along a two-dimensional direction, or let's say it moved in a plane. And suppose let us say a fly is flying in space. A fly will be flying in space, it will be moving along the three-dimensional space, or let's say all the three position coordinates will be varying with time. Generally how we can depict motion in two dimension, you can see here. Let me draw a graph representing the displacement along the vertical direction and along the horizontal direction. Along the horizontal direction we are mentioning by x, along the vertical direction I am mentioning by y. Let us say the trajectory, the path followed by the particle is somewhat like this. Let us say it is going along a path given by this way. That is, the y coordinate and x coordinate are related as per this curve. Now suppose at some time t, the particle is at this point A. Let us say at some time t1, the particle at this point A, its coordinates are given as x1, y1. After some time, that is at time t2, let us say the particle reached point B and its coordinates are given as x2, y2. Now this point, let us say this is x1, this will be x2, and similarly we can also mention about the y coordinates, that will be y1 here and that will be y2 here. This was all about, we can see the path is not a straight line, it's a different path but not a straight line. Now this is actually the trajectory. By trajectory we mean the path followed by the particle. Now let's say during some moment, during some instant of time, the particle is somewhere here. Let us say the particle is somewhere here, its coordinate is given as x, y, the general coordinate. Now the particle is trying to move along this path. That is, its net velocity will be directed along this path, along the tangent of the curve. So we may write one more point, direction of the particle is along the tangent of the curve. Direction of particle is along the tangent of the curve. First point we got, how can you find out the direction? The direction is very simple that you can make out. It's along the tangent of the curve that we have drawn while showing how the particle is moving in space. Second thing, same will be the direction of velocity. Just now I told you, the velocity will be directed along this direction. So I'm mentioning this by velocity vector v. Now if I resolve the velocity along the two directions, those will be the components of this velocity. Along x direction we can mention by vx, and along y direction we can mention by vy. So we got that vx is the component of velocity along horizontal direction and vy is the component of velocity along the vertical direction. If we mention this as angle theta, what theta will signify? Theta will give us an idea. About the direction of the particle, how it is moving. You see this diagram and easily you can make out that tan theta is equal to Vy by Vx. That is very clear from the diagram. What we obtain, theta is equal to tan inverse Vy by Vx. Actually, with this theta, we can specify the direction along which the particle is moving in the space. Theta is equal to tan inverse Vy by Vx. Now, how can you give the position at some particular instant of time? That will be given by the coordinates, the x coordinate and y coordinate, that will signify the position of the particle in space. Direction will be given by the angle theta, and that is actually tan inverse Vy by Vx. So let's come to some point. First thing, direction that is actually theta, that will be tan inverse Vy by Vx. First point. X and y are obviously the coordinates of the position coordinates of the particle. Second thing, let's talk about acceleration of the particle, and let us see what is the acceleration of the particle as it moves. Now see, we all know that, we all have learned acceleration is actually rate of change of velocity. Now see, as the particle is moving in a two-dimensional space, it's moving along in a plane, so it will be having x coordinate and y coordinate, and it's having a velocity along horizontal direction and velocity along vertical direction. So acceleration will be also having two components. So acceleration along x-axis, acceleration can be divided into two components. Acceleration along x-axis, that comes out to be, you may check this, I am mentioning this by ax, and we know as acceleration is rate of change of velocity, this can be written as ax is equal to dvx by dt. First thing, we got this. Second thing, acceleration along y-axis, so I am mentioning here acceleration along y-axis. See what will, it is very simple. I know you are all thinking in the right way. The acceleration along y-axis will come out to be dvy upon dt. We got two things, but one thing, don't get confused. If let's say acceleration along ax is somewhere like this, don't get confused that. Please make a correction in your mind. If ax is here, ay is here, and if you think that the net acceleration is somewhere here, that's right, and that this angle is, let's say, phi, don't confuse it with theta that already we have given for the direction. For direction, remember, you have to see what is the angle between Vy and Vx, what is the angle actually between the net velocity and Vx, that is the actual direction of the particle. This is not, do not use this for direction, so do take caution, do not use for direction. So one caution that you need to take for theta signifying the direction, do not take that tan inverse ay by ax will be the direction of the particle while moving in space. This was all about velocity and acceleration. Let's come and understand about the trajectory of the particle. Now you see here, I was saying this is the path followed by the particle. If I use the term trajectory of the particle, so what is trajectory? Trajectory is actually an equation which will give you the relation between x coordinate and y coordinate. So trajectory followed by the particle, trajectory of particle, you can say also an object. Generally we will see this in a better way when I teach you about projectile motion. Before that, let me tell you how are you going to find out trajectory of a particle. Let us say the y coordinate is varying and the x coordinate is also varying. The relation, the equation having relation or showing relation, having relation between y and x is actually the trajectory of particle. Having relation between y and x is trajectory or equation of particle, Okay, so you can find out what trajectory is followed by the particle by finding a relation between x coordinate and y coordinate. So generally how we do it, you will be given x is varying with some relation, y is varying with some relation. Generally it will be given as x is varying with some time, and y is also varying with respect to time. The equation will be provided. Try to eliminate time from one of the equation and try to find a relation between y and x. See, we will understand how to find the direction, how to find the trajectory, how to find the acceleration with one equation, with one example that I'm going to show you just now. Let's come to the example showing the relation between x and y, and let us find the direction of the particle. Let us do an example to understand the concept that we have just done. Let us say a particle is moving in space that is along x direction and y direction such that the x coordinate, or let's say the velocity along the x direction, is given as velocity along x direction is given as Vx is equal to, let's say, 5 meter per second. You may take any value for this example. I am giving Vx equal to 5 meter per second. And let's say the velocity along the vertical direction is dependent on time, and the time dependency is given as velocity along y-axis is given as Vy is equal to, let's say, 3t meter per second, where t is time. Okay, that's very easy. That means that t goes to 0, the velocity along y direction will be 0, and as t increases, the velocity along y direction will increase. Suppose the question is find, the question comes, first one, what is the speed of particle, let us say, at t equals to 5 seconds. So find speed at t equals to 5 seconds. First thing is required. Second, direction at t equals to same, direction at same state of time at t equals to 5 seconds. Third, it has been asked, find the acceleration of particle at t equals to 5 seconds. Find acceleration at t equals to 5 seconds. We can do this at t equals to 5 seconds, find acceleration. Fourth, give the trajectory, or write the equation of particle. Write the equation of particle. Means equation of trajectory of particle, that is the more suitable word. Equation of trajectory of particle. How to find out all these given basic details? First thing, only given thing, that Vx and Vy, and we have to find out at some different instant of time at t equals to 5 seconds, what is the speed, what is the direction, what is the acceleration, and we have to find the equation of trajectory of particle. One more we can add for us, also find the displacement. You can add find displacement in t equals to 5 seconds. A simple example, you will see that how we can solve for two-dimensional motion. And let us do this basic question. Hope the question is visible to you all. See here. Velocity along x-axis Vx 5 and Vy is 3t, that is only Vx is constant. Vx remains constant, that is constant, and Vy is regularly increasing with time. First thing is speed at t equals to 5 seconds. Now say Vx is 3, that's constant. Now at t equals to 5 seconds, now see Vy we have 3t meter per second. So at t equals to 5 seconds, let us find the value of Vy. Vy will come out to be 3 into 5, that is equal to 15 meter per second. The first thing we got Vy. So we will get a speed. Speed we know that is the magnitude of velocity, that will be equal to Vx whole square plus Vy whole square. Find out this value, you will get 3 whole square plus 15 whole square. Find out this value, so you will get the answer. 3 whole square is 9, 15 whole square is 225, 225 plus 9 you will get 234. So under root 234 meter per second is the speed of the particle at t equals to 5 seconds. Suppose the question even asked what the velocity at t equals to 5 seconds. So we have to specify the magnitude with direction. Here I will tell you one more simple term to represent the standard way of answer, that is if you want velocity. So velocity at t equals to 5 seconds, you can represent with I cap and j cap notation. So this will be simple. You see Vx equal to 3. So here I will write Vx I cap plus Vy j cap. This is the velocity of the particle with proper vector representation. Now you see here Vx is 3 and Vy is 15. So 3 I cap, hope this is visible till here, plus 15 j cap. I believe that you all can see till here. Now after this we are required find the direction at t equals to 5 seconds. Now the direction is already hidden in this information. You all can easily find out the direction, and yes, you have got the right idea which you are thinking. It's tan inverse Vy by Vx, or I will rub this part. Hope you have noted down this. The required information I'm keeping on the board and rest part I'm rubbing so that you can simultaneously see the question and see the answer. Next comes for direction. Just now I told you direction, it's actually tan inverse Vy by Vx, or if I represent this as Vx and this as Vy, the particle will be trying to move along this direction. This is the net velocity, let's say this is theta. So tan theta will be equal to Vy by Vx. Tan theta is equal to Vy by Vx, and from here theta is equal to tan inverse Vy by Vx. So I can write theta is equal to tan inverse Vy by Vx. Substitute the values, you will obtain tan inverse Vy. Vy is 15, because 5 into 3, 15 divided by 3, it will become tan inverse 5. So this is the direction along which the particle is trying to move. Theta we got as tan inverse 5. Now let's come to the third part, that is acceleration at t equals to 5 seconds. For acceleration, if you see, I'm keeping these two equations as it is and I'm rubbing this part, hope you have noted down. For the acceleration portion, Ax, just now I told you it will be dvx by dt. Now see, since velocity along the x direction is constant, velocity along x direction is constant, so that will be 0, and acceleration along y axis is dvy by dt, and since dvy by dt is 3t, this will be actually equal to 3 meter per square second. So the acceleration is only acting along y axis, and that is given as 3 meter per square second. So we are enough here, we can write acceleration as simply a is equal to 3j cap with proper units. This is the exact representation. Fourth one, equation of trajectory of particle. Most students get confused here how to find out the equation of trajectory. It's not too tough to do it. See here, at any instant of time t, the distance traveled along the x direction. Now see, for any time t, let us find out the distance traveled along the x direction. That will be given as x is equal to vx into t, or to be more specific, I am writing displacement along x axis. Displacement along x axis will be given as x equal to vx into t. The second part, the displacement along y axis, that is what is required, because here you see vy is equal to 3 into t. Now you see, we know that vy is equal to dy by dt. Therefore dy is equal to vy into dt. That's clear. Now I am using this part, dy is equal to vy into dt. So if you want to find out the value of y, so integrate both the sides. Dy is equal to integration of vy into dt from 0 to t. Vy value is given as 3t. So 3t dt, substitute the value of velocity, you will get 3t square by 2. This will come out to be 3 by 2 t square. You can substitute the limit. So this is the value of y and this is the value of x. X equal to vx into t we got. You substitute vx as 3, you will get x equal to 3 into t. We got x, we got y. I am keeping here x. Now here you can see t can be written as x by 3. T can be written as x by 3. Substitute the value of t from this equation in this equation. So you will get y equals to 3 by 2 t square. On substituting the value of t from this to this, you will get 3 by 2 and t square. So x by 3 whole square, or this comes out to be, you can see 3 will cancel out. So x square by 6 will be the result. Y equals to x square by 6 is the answer for this. Yes, this will be the right answer. Y equals to x square by 6. In this way you can calculate how to find out the trajectory of the particle for any instant of time. This is actually the trajectory, the general equation, and actually this is the equation of a parabola also. Y equals to x square by 6, this is the equation of a parabola. Next comes the last part, the displacement in time t equals to 5 seconds. For this, the displacement in t equals to 5 seconds, already I have the solution is here only. So what I'm going to do, I'm going to use this part of the board to find out the displacement in t equals to 5 seconds. Now you see, x was given as vx into t. This is the fifth part of the question. Vx is 3 and time is 5, so 15 meter will be the displacement along the x-axis. Now let's try to find out the displacement along y-axis. Y was given as 3 by 2 t square. Just now we derived, so substitute the value of t as 5, so 3 by 2 into 5 square, that is 25. 25 into 3, 75. 75 by 2 will give you 37.5. That will be equal to 37.5 meter. We got displacement along x direction, displacement along y direction. Net displacement will come to be, with proper notation, net displacement, you can mention your answer in I cap and j cap form, that is 15 I cap plus 37.5 j cap. This is the answer. This is your final value of displacement. With this question we have learnt about how to find out the speed, direction, acceleration, trajectory and displacement. You must revise this question so that you may solve other questions based on the same pattern. I want you all to note down here, and I will start from here. Okay, hope you have understood this question, and just make one correction. I have used velocity x along x direction as 3, so you can make this as 3 instead of 5. Now you would have understood about two-dimensional motion. You would be having a basic idea. Now if you practice 2 more problems, the concept involved in two-dimensional motion will be very much clear to you all. Finding the direction, finding the trajectory, finding the acceleration, velocity and even the displacement for different time periods, for different instants of time. Let us do a different question, and this is a question which will tell you what to do when displacement is given as it varies with respect to time t. What I mean to say, let us do a question. I have a question. It says that a car starts moving from rest on a horizontal ground such that the position vector of car with respect to its starting point is given as r equals to, mentioning the important points, r equals to bt I cap minus ct square j cap. This is the value of position where a and b are positive constants as obvious, and I cap and j cap are the unit vectors along two perpendicular direction x axis and y axis intersecting at the starting point of car, that is origin. Find the equation of trajectory. So first of all we have to find out equation of trajectory. This is the first part of the question. Second part is the angle between direction of velocity and acceleration of car. We have to find out angle between velocity and acceleration. One more line is even enhanced in this statement, and that is angle between velocity and acceleration of car as a function of time theta equals to ft. We have to find as a function of time, we have to find out. Now see here, 2 parts. It's only given that how the position of the car is varying, r equals to bt I cap minus ct square j cap. Now see, from this given detail we can write x coordinate or x component of displacement will be given as bt and y component will be given as minus ct square j cap. It is actually in the downward direction, so don't worry, write it as it is minus ct square. Now we have to write out the trajectory of the particle. Trajectory of the particle will be written as, you just substitute the value of time t from here and substitute it here. So time t is equal to, from first equation, from equation number 1, from 1 t can be written as x by b. Substitute the value of t in equation number 2. So substituting into, see what we are going to obtain. The value of y will come out to be minus c, and t square will be actually equal to x by b whole square. So minus c x by b whole square. This comes out to be y equals to minus c upon b square into x square. This is the value of equation of the trajectory of the particle. This is how y component of displacement and x component of displacement will be related. Let's go further. And now you see angle between velocity and acceleration. So let us write the velocity and acceleration. The second part of the question. Velocity component along x-axis, let's mention by vx. Vx will come out to be dx by dt, and if you see dx by dt, that will be equal to, from this equation, x equal to bt, so dx by dt will be equal to b, and vy will be equal to dvy by dt, and that will come out to be, you may check here, that was given as minus ct square. This will be minus 2ct, minus 2ct. So we can write velocity as, bi cap minus 2ct j cap. This is the exact representation. Now if you want to find out the acceleration, the next part, find out the acceleration. Acceleration will also have two components, as I have told you, ax, and that will be equal to dvx by dt, and this will be equal to, just differentiate the dvx by dt, that will come out to be 0, and ay will be equal to dvy by dt. This will come out to be minus 2ct, differentiate, you get minus 2c. So acceleration can be simply written as minus 2c j cap. This is the value of acceleration. We got this. Finally, in vector form, acceleration is this and velocity is this. We have to find out the angle between acceleration and velocity. Now if you remember, I told you the angle between two vectors is given as dot product of the vector divided by the product of the magnitude of the vector. Now see, magnitude of velocity can be written as under root vx square plus vy whole square. This is the magnitude of velocity. Now vx whole square, that will be b whole square, plus vy whole square, that will be equal to minus 2ct whole square. So minus 2ct whole square. This comes out to be under root b square plus 4c square t square. Plus 4c square t square is the value of velocity. Let's come to and find out the value of magnitude of acceleration. That's very simple. That's only minus 2c. So acceleration magnitude will be only equal to 2c. We got this. We got the magnitude of velocity, magnitude of acceleration. Let us find out the value of angle between the two. If you remember from dot product, a dot b was given as ab cos theta. So cos theta will be written as a dot b upon ab. Cos theta will be simply a dot b upon ab. Let us do this part here to find out the angle between the two. Hope that as I do, this is visible to you all. We are mentioning it from here, not a problem. We can do it from here. So angle between the two, cos theta will be equal to v dot a divided by magnitude of v into magnitude of a. We have to do this. Now v was represented as, we have already represented bi cap minus 2ct j cap. So represent it as bi cap minus 2ct j cap. Take dot product with a, that is minus 2c j cap, divided by their product of their magnitude. So under root b square plus 4c square t square, and multiplied with magnitude of acceleration, that is 2c. So we got this. Now see what you will obtain in the numerator. bi cap, I cap dot j cap will give you 0. So take j cap dot j cap, minus into minus will go plus. So plus 4c square t here will be obtaining, and here we have 2c. So 2c and under root b square plus 4c square t square. Obtained. C and c will be cancelled out. So theta will come out to be theta will be equal to cos inverse of this value. So theta is equal to cos inverse c and 2ct divided by under root b square plus 4c square t square. This is the value of the angle, and this angle is the angle that is also a function of time t. Hope that you have noted down here, and I will continue from here. Okay, hope you have taken down this. One more good question we have done, even the angle between velocity and acceleration we found, and that was different to the direction of motion of the particle. This board acquires a lot of dust as we regularly use it. I hope that when we write something, it's clear to you all. Let's go with the next question. I have one more good question, and I will tell you. You may also record this statement as I read it out. The coordinates of a bird flying in the xy plane are x equal to 2 minus alpha t and y equals to beta t square. This is the coordinate of the position of bird as it flies in space. Given that where alpha equals to 3.6 meter per second, given alpha is equal to 3.6 meter per second and beta is equal to 1.8 meter per square second. This is the given value of beta. Calculate the velocity and acceleration vectors and their magnitudes as function of time. So we have to find velocity, we have to find acceleration, and both as function of time. This is the first part of the question. Second part says that also find the magnitude and direction of bird's velocity and acceleration at t equals to 3 seconds. So find magnitude and direction of velocity at t equals to 3 seconds. Third, find direction at t equals to 3 seconds. This is what we have to find out, and acceleration also at time t equals to 3 seconds. The fourth part, acceleration at t equals to 3 seconds. This is all we have to find out. Now if you remember, all these patterns I have already discussed in theory portion. Here we will see what more we can do. Here you see how x varies and how y varies is given in the form of equation, and the relation is with respect to time t. Now if you remember, Vx was given as dx by dt. Let's do the solution very fast. So dx by dt, that will give us d by dt 2 minus alpha t. So since differentiation of constant will be 0, this will give me minus alpha. This is the only thing that we have. So we got Vx is constant, that is equal to minus alpha, and that is equal to minus 3.6 meter per second, and that is, it will be directed towards the negative x-axis. That is the value of negative, that is the implication of negative sign here. Now let's come to Vy. Vy is actually equal to dy by dt. Dy by dt, this will be equal to, keep y as beta t square. So this will come out to be, if you check, this will come out to be, take 2 outside, will be 2 beta t. So 2 beta t is the value of velocity along y-axis. So we can write velocity proper vector notation as minus 3.6 I cap plus 2 beta t j cap. This is the value of velocity with proper vector notation. So we got the value of velocity. Now let us find out the value of acceleration. Acceleration along x-axis is equal to dvx by dt. d by dt vx, dvx by dt will give you 0, since velocity along x direction is constant. Acceleration along y-axis, this will give you dvy by dt. dvy by dt, this will come out to be, you check dvy by dt, if you do, you have to differentiate this, you will get 2 beta. So acceleration is constant again, so you can represent same with proper vector notation. A is equal to 2 beta j cap. Did? Now it has been asked, find the velocity at t equals to 3 seconds. So velocity at t equals to 3 seconds will be given as, substitute the value of t as minus 3.6 I cap plus 2 beta t j cap, you will get minus 3.6 I cap and plus 2 beta t j cap, so plus 2, value of beta that is equal to, we have already noted on 1.8, so 1.8, and value of t you have to represent as 3 j cap, so you got minus 3.6 I cap plus 2 into 3 6, and you can say this 2 into 1.8 will be 3.6, this will give you 10.8 j cap. Now if you want to find out the magnitude, actually if you want to find out the magnitude of velocity at t equals to 3 seconds, that will come out to be, take under root of this, you will get minus 3.6 whole square. Already I have told you the method that you have to apply. This will be the value. You can easily keep the values, and you get the required result for the magnitude of velocity. Let's come and find out the magnitude of acceleration. I'll use this part. Now see, acceleration along x-axis is 0, acceleration along y-axis is 2 beta. So let's mention here acceleration along y-axis is 2 beta, and that is a constant value. So just substitute the value of beta, and beta is 1.8. So 2 into 1.8, that will be 3.6 meter per square second is the value of acceleration at t equals to 3 seconds. Now comes the direction. The direction at t equals to 3 seconds. So direction, if we talk about, I told you direction is given as theta is equal to tan inverse Vy by Vx. Simply substitute the value of Vy and Vx here. See what you're going to obtain. Vy is 10.8 and Vx is 3.6. It's along the negative x-axis direction. So what you do, substitute with proper notation, this will come 10.8 upon minus 3.6. See what you're going to get. You're going to obtain 10.8 by 3.6, that is equal to 3 tan inverse minus 3. Have a good idea about it, what we are going to find actually when you are getting tan inverse something of a minus negative of an angle. You see here, this will be Vy and this will be Vx. This will be Vx in this direction and this will be Vy. When we say we got tan inverse minus 3, if this is the net velocity, we have measured the angle along this direction. You will get this as the angle tan inverse minus 3, and this is showing that this angle is an obtuse angle. Now we have also mentioned acceleration at t equals to 3 seconds. We have already done that. We have done with velocity, we have done with direction. We have found out the general formula. What I want from you all, after the class, do see how we can find out the trajectory of the particle, the velocity, the displacement and the acceleration. You see, for different questions, you have to apply the same thing. Try to find a relation between y and x in some common term. Let's say x has a relation with respect to time. It will be given as how it varies with time. Y will be also given how it varies with time. Try to eliminate time from both the equation and try to find a relation between y and x. You will get the trajectory of the particle. Second thing, when we talked about the direction, try to find out the velocity along the x direction, find the velocity along the y direction. The direction will be given as tan inverse Vy by Vx. One more thing I will like to add before leaving you all for today's class. Note that we have got two components of acceleration, ax and ay. See, the component that is along the velocity, the acceleration component that is along the velocity, that is actually responsible to increase the magnitude of velocity. So you may note down some special points about today's class. Component of acceleration along velocity or tangential acceleration increases the magnitude of velocity. Tangential acceleration increases the magnitude of velocity. Tangential acceleration increases the magnitude of velocity. Next thing, if we have a normal acceleration, that is acceleration acting normal to the path of particle, that acceleration component will be responsible to change the path of particle. So second point, note down, component of acceleration normal to path of particle, component of acceleration normal to path of particle normal to path of particle is responsible to change the direction of particle, is responsible to change the direction of motion, is responsible to change the direction. Okay, hope these 2 points will be very much useful for you all in the coming section when we learn about circular motion. In the next class, we'll talk about projectile motion. We'll see that how a projectile moves, and it is actually generally, I'll show you a very quick representation. Actually, if I throw it in space in this way, it is actually path of a projectile. You will see that the motion performed by this chalk holder is actually a projectile motion. So we'll see the detail in the next class. Till the time, thank you everyone, do revise, and from here we'll continue in the next class. This is Abhinav signing off.